Welcome to an intellectual extension of Professor Yossi Aviv's Operations Strategy course. We are exploring the evolving nature of digital systems. For decades, executives have operated on a specific promise. If an organization invested enough capital into planning systems, data warehouses, and machine learning models, it could predict the future accurately enough to run smoothly. Yet, despite access to computing power that would have been unimaginable a generation ago, many leaders find that their organizations are becoming more erratic and difficult to manage. Customer preferences shift overnight. Entire business models appear and disappear within a few years. Software systems fail in ways no engineer anticipated. Executives often assume that gathering vast amounts of data will eliminate the baseline uncertainty of business. In reality, the challenge of the unknown remains. Advanced computational power has solved many logistical puzzles, but it has not rendered the future knowable. The reality of the hyper-fast digital age is governed by two legacy operational assumptions. They were true decades ago, and they have become more critical today. First, actual customer needs will always differ from what an organization planned. Second, abnormalities and unexpected edge cases will inevitably emerge during execution. It is a common misconception that feeding a higher volume of data into a sophisticated AI model will eventually neutralize these two rules. But these occurrences are not signs of poor operational planning. They are the permanent underlying physics of the modern digital economy. It seems reasonable to ask why predictive analytics can't simply map out exactly what customers want before a product goes to market. The friction lies in a core reality of software development. Users themselves rarely know what they will value until they actually interact with a live product. Product teams repeatedly spend months building highly engineered features that go entirely ignored, only to watch a minor capability, added as an afterthought, become the primary draw. The emergence of generative AI illustrates how quickly these expectations can be overturned. This chart shows the trajectory of AI adoption that many experts forecasted just a few years ago. The consensus was that AI's future would be embedded inside highly specialized business processes. Then, conversational AI reached the mainstream. Millions of users adopted the technology in ways that no forecast had accounted for. New use cases emerged weekly, forcing developers to reimagine entire categories of software almost overnight. The market wasn't won by the firms with the most accurate forecasts. It was won by firms capable of rapidly pivoting when reality diverged from their expectations. This dynamic dictates outcomes far beyond software products. Emerging service ecosystems, like modern telehealth platforms, operate under the exact same constraints. Static demand forecasting fails here because telehealth is subjected to wild external variables, sudden public health events, viral social trends, and localized media coverage. Instead of trying to perfectly anticipate these exact spikes, modern platforms focus on building flexible systems that can instantly absorb anomalous demand. The strategic focus shifts away from the pursuit of a flawless plan. The operational imperative is now measured by the speed of adjustment, how quickly an organization can reconfigure when the initial plan proves wrong. This leads to the second major misconception, the belief that advanced digital infrastructure gradually eliminates operational problems and errors. While technology increases a system's capability, it simultaneously increases its systemic interconnectedness. High interconnectedness naturally breeds entirely new forms of failure that cannot be preemptively modeled. Agentic AI provides a clear look at how this functions. The potential of AI agents operating autonomously, coordinating software and executing tasks with limited human intervention, is immense. This network map shows the paradox of autonomous execution. An agent can execute its coded instructions flawlessly, optimizing a specific metric, while inadvertently causing damage to an unmapped part of the business. An autonomous workflow might perform perfectly 1,000 times before hitting a rare condition that triggers a chain of unintended outcomes. These failures are not the result of bad engineering or poor design. They are the inevitable byproduct of operating within highly complex autonomous environments. This pattern is embedded directly into the structural backbone of the digital age, cloud computing architectures. A seemingly trivial configuration change in one microservice can cascade outward, disrupting dozens of interdependent services in an instant. The same dynamic applies to cybersecurity. Massive incidents rarely start with a loud alarm. They usually begin as a tiny abnormality that algorithms fail to recognize as significant. Digital organizations face a specific challenge. Technology simultaneously scales operational capability and scales systemic vulnerability. Because complexity guarantees abnormalities, a system's resilience, its capacity to absorb a shock and recover, is often more important than its predictive accuracy. If data cannot reliably predict the future and technology guarantees new failures, what defines competitive advantage in the AI era? The standard industry answers point to having the best algorithms, the most data, or the highest computing power. Those elements are necessary, but they are no longer sufficient. First, outperforming organizations are structurally designed to adapt the moment reality deviates from their forecasts. Second, they engineer their operations for rapid response and containment when inevitable abnormalities occur. We see this in software firms that utilize continuous release cycles to adjust in real time, and in AI-native organizations that treat rapid experimentation as a core operating principle. These firms have abandoned the pursuit of algorithmic optimization of the planned. They focus on systemic resilience against the unplanned. The coming years will bring more sophisticated forecasting models and more powerful AI automation. Despite those advancements, reality will continue to surprise us, and complex systems will continue to fail in unpredictable ways. The executives who thrive are those who accept this baseline truth and abandon the search for a perfect crystal ball. Because ultimately, the future belongs not to organizations that predict perfectly, but to organizations that adapt effectively when reality refuses to cooperate.